Right, Debbie Can here with another question from your Hayes and Harris Math SL textbook. This is Chapter 8C.3, and we're looking at Question 6, Part A. We're told to use a unit circle diagram to find all the angles between 0 and 4 pi that have a cosine of root 3 on 2. Now, we're told that there's more than one, so we're going to be finding multiple values. And we're also going 2 complete rotations around the unit circle. One complete rotation is 2 pi, and we're going all the way to 4 pi. And we want to find those angles that have a horizontal component of root 3 on 2. We're told to use a unit circle, so the first thing we'll do is draw a unit circle. And the first thing that I notice is that the cosine of the value is positive, which means we're on the positive side of the Cartesian plane over here. Let's draw in some things that we know about the unit circle. First off, pi on 4 is one of the major ones, and it's right here. If you go another quarter rotation, that takes you to pi on 2. But then there's also a couple in between. And they're not directly in between. They're not eighths of pi. They're sixths of pi. There's one here at pi on 6. And there's one here at pi on 3. Then finally we also have 0 radians. That's the first quadrant filled out. Each of these major angles correspond to positions along the x-axis. For example, there's 0, there's 1, here's 1/2, and then there's these two. 1 on root 2 and root 3 on 2. So that's 0, 1/2, 0.707, 0.866, and 1. The one that we're interested in here is this one, root 3 on 2. We're looking for the angle that has this horizontal component. Well, it's pi on 6. So the angle could be pi on 6. But as we already know, there's more than one solution. There is another angle that has the same horizontal component. To find it, we go down to here. This is the mirror image on the other half of the unit circle, and it has the same horizontal component. You could say it's negative pi on 6. That'd be accurate. But we're told that the answer has to be between 0 and 4 pi, so we're not allowed to rotate backwards. Instead, what we have to do is rotate forwards, a whole rotation, and then go back pi on 6. So one of the other solutions is going to be all the way around 2 pi, take away pi on 6. All the way around, and then reverse pi on 6. 2 pi is the same thing as 12 pi on 6, and 12 pi on 6 take away 1 pi on 6 gives me 11 pi on 6. And that's my other unique solution, 11 pi on 6. There are more, though, because we're allowed to keep rotating. So we can rotate to pi on 6, and then 11 pi on 6, and then go again for a whole second rotation. So we go all the way around 2 pi, and then again to pi on 6 again. So there's 2 more solutions for the second time we hit these positions. And they'll occur at 2 pi plus pi on 6 and 2 pi plus 11 pi on 6. So we have our solutions plus another rotation. That's 13 pi on 6 and 23 pi on 6. So all in all, my solutions are pi on 6, 11 pi on 6, but then for the second rotation, 13 pi on 6 and 23 pi on 6.